me start the recording again. I'm not seeing you. This class is so important. Watch the video lecture. Okay. Symbolic math. We'll be trying to finish it up by today. If not, a little bit left. Whatever, we'll be finishing up in next class. Usually in last class, I don't like to do too much. Just like to address any question, concern, or whatever. This is the last topic, obviously, that we are covering called symbolic math. And the first section is theory. This theory is in a sense like I'm sorry, it should be coming on that screen. Still restarting this thing. Hopefully it is gonna show up. The thing is on record. Anyway, the theory that I was just saying is not like you are gonna ask in the final, do this differentiation, do that. But I'll ask you do this by using MATLAB or Octave, right? Symbolic math. So I'm gonna do a quick review kind of a thing. And review things means like I'm gonna show you some of the differentiation, some of the integration, those sort of thing. Okay. You guys may want to take notes, means like pen and paper from this point on, because you're not gonna have access what you're seeing it now. I think I started recording, but you can see the recording still. So let's start with the class note. Any question? Why that is not showing up? I can't take it anymore. It's the extreme frustration. All right. Finally. Everyone's ready now? Let's start with the differentiation. Let's see if you remember the differentiation. First of all, by using the symbolic math, you can solve the quadratic equation. You can solve the system of linear equation. I did talk about it, right, in last class. To give an example, say like you have this x plus 5y equal to 10, x minus 10y equal 20. Can you solve x and y value? So this is called two equations, two unknowns. Solve it, system of linear equations. Now quadratic equation is, say like you have x square plus bx plus c, right, equal to 0. You remember the x has two solutions, right, because it's a quadratic equation. There is a square, and then you have minus b plus minus square root b square minus 4ac divided by what is, anybody remember, 2a, right? All right, so now this could be another equation. Now obviously you will have a, b, and c. Instead of a, b, and c, you'll have some number, right, numeric number. To give you an example, say like if you have 5x squared 10x plus 1 equal to 0. Now if you'd like to find the solution of x1 and x2, means two solution for this quadratic equation, you can use the symbolic math. Any questions so far? Is good? All right, moving on to differentiation and integration. So on the differentiation, they call derivative, right? On the differentiation, do you guys remember this x to the power n equal n x to the power n minus 1? Do you guys remember that? There's the first equation in differentiation, right? The very first equation. Now, if I'm giving you examples, say like do the derivative of x squared with respect to x, right? How am I going to do it? I mean, there's different way people do it. They first name as like y equal to x squared and then do dy over dx, right? And then they use this 2 as like n. Assume this is n value is 2, right? Okay, and that's the assumptions only. I'm not going to put it so you won't be getting confused. But basically my goal is to write x n to the power and x square, sorry, n x to the power n minus 1. Now if the value of n is 2, right, so I'll be writing this 2 minus 1. So 2 minus 1 is like 1. So this is the result, right? Remember? All right, so that's again the very basic one. So we'll be solving that as well. And then let's do another one. See, if you have a constant here, right, what would be the value? You know that it is 0. C means constant, obviously, right? So C is a constant. Now how do you know this? This is the equation. We do know, you should know it, right? I mean, if you'd like me to go a little further, I would be going this way. You know, x to the power 0 is what? 1, right? So this is the same thing I'm writing, right? So then, you know, you have this C is a constant. I don't care about that. I'm gonna take it out, and I'm gonna do the derivative of x, and then anything multiplied with 0 is what? 0. So the whole thing is 0. All right, so now let's move a little bit forward. So if I'm gonna give you another example, say like d by dx and then x to the power 5 by 2. Can you solve it? All of you solve it. I would like to see the result. See if you can got it. That way you're gonna, you know, engage with whatever is happening here. No, you need a pen and paper to solve this. You would have pen and paper? Class note? No. Borrow it from your buddy. Borrow it from Ethan. Ethan, you have paper, pen. Paper, you can find it from the printer. Pen. Yeah. Okay. There's no? I can see some pen here. You can borrow it. Most likely this is my pen. I sometimes left it here. Ethan, you have a result? Not yet? You remember 5 by 2 is n, right?
Yeah, I wasn't taught this way. The way that we did it was not this, so I'm trying to make sure I'm doing it correctly.
You do it one way. I'd like to see the result only. Okay, I'll do it my way. So if the result is same, that means we are both correct. You got it, Jason, right? So your n is what? 5 by 2? So you should be writing x n to the power, sorry, x n x to the power n minus 1. So I'll just simply plug the value. Okay. So I'll have 2, 5 minus 2. 5 by 2, x to the power 3 by 2. So this is 2.5, x to the power 1.5. Is that the value you got? Do it your way, any way, whatever way possible. This is the result you should be finding. If that's the result you find, that means you're getting correct. We found the same result. All right, so now let's move on. Next topic. So this is a little complex. See if you can get it. So you have this 10x okay multiplied by x to the power 5 by 2 plus 5. See if you can solve this derivative of this. Now you might be wondering, so let me help you with something. See, if you have this y equal, say like I'm trying to give an example, say like x square plus I don't want to give you exact thing, so I'm solving it. Say like AB, and A and B both are function of x, right? So you guys remember the product rule? So it should be what? dB by dx, right? You guys remember? B dA by dx. Everybody remember this equation? That's called product rule. This is called product rule. So let me write it here. Product rule for derivative or differentiation, whatever way you want to say. I'd like to write differentiation. DIFF dot means differentiation, right? You guys remember that? So now you have here the thing that I wanted you to solve. Say like this is A and this is B. Can you do that now? If I'd be in your position, I'd be probably doing this way. So I'd be writing 10x and then this d by dx and x to the power 5 by 2, right? Plus I'll be writing x to the power 5 by 2, then d by dx, right? And this 10x. This d looks a little weird. Hopefully you understand. Plus I'll be writing d by dx 5 square root means 3 by 2, right? It's the same thing. Ever get it? Can you solve it now? This won't be that bad because if you remember, and again, if you remember, so you see, if you're gonna do the derivative of 10x means d by dx, that's the equation, by the way. Ethan, you remember what is the derivative of 10x? Secant. Yep, you are absolutely right. Sec x or secant. You can say secant, right? Sec x. So you need to know this equation, right? If you're gonna do the derivative of sin x, it become cos x. If you do derivative of cos x, it become negative sin x. If you remember those, right? You don't need to deal with sin x and cos x. And on the top of everything, what I'm saying, nothing that you have to do it manually on the exam. Everything would be done in the software itself, like Octave or MATLAB. But you need to know what is going on the background, right? Just a review. That's what we are doing, right? Just to give you a heads up. So yeah, solve it. See if you get it. Do you have a final answer? Now your goal should be getting this final answer as like 5 by 2 x to the power 3 by 2 10x x to the power 5 by 2. By the way, this is sec x square. That's the result. Sec square x, then 15 by 2 x to the power half. Now this is the final results you should be finding. Now obviously you gotta do, I'm putting dot means you gotta do it the intermediate step. Do it. See if you get it. If you get it, that means you're good. I can move on.
That's 5 square root x to the third. Or 5 square root x to the second.
5 square. What are you referring, Ethan?
So in the original equation, it's 10x plus x5 x to the 5 divided by 2.
Oh, that's the multiplication here.
Yep, so that makes sense. It's the very last term, 5 square root.
Oh, x to the power 3.
Okay, it's into the third, not into the second.
Yeah, that's the 3. So that's why I had this 3 in the numerator and 2 in the denominator.
Oh, I see. Okay. Yeah.
Yeah. Jason, you got this value, the final result? Ethan, you got it? Jason, you got it, the final result? All right, moving on. Okay, so I can go on with this, like, and another example, possibly, say like y equal x square plus x plus 2, right? And this would be 2x plus 1. So should we know this thing without going in detail like that first. And if I'm gonna do the differentiation one more time, right, second time, I should be writing this way. You guys are familiar with that? Okay, so then if you're gonna do the differentiation of these, you see there is a 1 on the top of x, you know that, right? So this 2 multiplied 1, x to the power 1 minus 1, and then you have a 0 here, right? Because 1 is a constant. Remember that? So then this become 2x. So this is like the second derivative. Why I'm showing it to you that in Octave or MATLAB, you can do the second derivative, okay? So that's something you can do as well. So we are doing this practice here. Jason, you have any question? You understand? Perfect. All right, so there is this other thing. You'll be learning this function called eval, okay? Eval means evaluation. You'll be learning, today, called solve. Solve is a function, okay? It will gonna solve the differentiation, and you'll be learning diff. Diff means differentiation or derivative, okay? You'll be learning how to solve the integration as well. Integration is int. I should be writing I is a small I, int. Okay, now we're gonna do some example with integration, okay? So for integration example, so let's do the integration. Okay, on the integration example, if you have x to the power n dx, all right, so then you have x to the power n plus 1 divided by n plus 1. You guys remember the equation for integration? Now that is something for integration. Okay, it's very straightforward. Remember, like the differentiation x to the power n is become n x to the power n minus 1. This is what for the integration. Okay, x to the power n, if you're gonna integrate it, it will have x to the power n plus 1 divided by n plus 1, and plus c is a constant. So that plus c will not gonna come if you have a limit, lower limit and upper limit. Okay, that something goes with the integration. Jason, you are not taking classes with integration yet? I just started now at the last week.
Yeah, it's got one, right?
Yeah, we can pretty much just talk about it and then
You touch up on it at the very end.
In Calc 2, they'll be learning it more.
Yeah, that's the whole point of Calc 2. Calc 2 is
All about the integration. It's all right, Jason. It's not like you have to do integration in the final exam or in homework, because the software would be doing it for you. But you need to know at least the basic by doing some basic things, right? So I said like limit and low limit. Okay, Ethan might be understanding it by heart what I'm saying. So you see, if you are trying to do integrate like x to the power n, instead of n, I would be say let's put a numeric number x to the power 3, right? What would be the result then? It's very straightforward. You should have, like, instead of n, you should be writing 3, right? Make sense? 3 plus 1. You got it? So the result should be x to the power 4 divided by 4. Now, if you are expert on this, you don't have to do these steps that I'm showing. You could be getting the results by seeing the integration, right? That easy. So then, after that, let's just... by the way, I didn't quite finish this thought process here. What could be the code for this? So like if you are trying to solve this x to the power, like this is the example that you're trying to do, right? So like you're trying to solve this, right? A second derivative. The way you should be writing it, two way you can write it. One is easiest way could be y comma 2, right? You see? So you're doing the derivative twice, or you can write the whole equation instead of writing y and everything, go through all the trouble. You could have write x square plus x plus 2 comma 2. Does it make sense? So you should be getting the result of 2x if you're going to do that. That means 2x. Jason, you got it? All right. So, I mean, the steps are important to understand, but I'm saying, like, if you know the code, then you don't have to do it. Okay, coming back here, the same thing is true here. Like you should be writing simply int. Okay, so this one, I'll be doing this thing here. So you should be writing only int. What would be writing? Int, again, y equal to x cube, then only y or x cube. That's it. It should be doing the integration for you. Any question? Jason, you understand? All right, and then obviously it will gonna give you the result of x to the power 4 divided by 4. All right, so after that, let me move on a little bit further. So what if you were interested to find the integration, the integration of the first integral again? Means you have x to the power 4 divided by 4, you'd like to do integration of that. Now, Jason, I know you just started it, but you should be able to solve it. So what I'm saying now, we'll try to do the integration of x to the power 4 divided by 4 dx. Can you do that? So first of all, anytime you are facing with differentiation or integration, they don't care the constant. They don't have anything to do with the constant. So if the constant stays alone for differentiation, we've seen it's 0. That's the result. If the constant stayed alone, you can still do the integration, but for integration, it's not 0, it's the constant. With that, if you are doing integration with respect to x, then it would be constant multiplied x. Why is that? Because you got to understand there is a 0 on the top of the 1 is equivalent to x to the power 0. So 0 plus 1 is 1, and 0 plus 1, yeah, that's how. Anyway, you'll be learning it more, but bottom line, if you are facing this situation anytime with a constant, first thing your job should be take out that constant from the integration. So make the integration simpler. So you'd be seeing only x to the power n. What is the value of the n in this case? 4, right? Can you do that?
Yeah.
What is the result, Ethan, you find? Ethan, you did it?
What's up, I'm sorry?
What is the result that you find for this?
It should be 1/4 times x to the 5th divided by 5.
1/4 multiplied 1/5 x to the power what?
X to the power of 5.
So plus c constant, because it's not a definite integral, it's an indefinite integral. Just remember, definite and indefinite integral, what does it mean? Definite means you have the limits upper and lower, right? And indefinite means it is the generalized solution. So you got to put a constant if it's indefinite. And then you have this x to the power 5 divided by 30 plus c. So that is the result you should be finding when you're going to do the integration again. Now, unlike the differentiation, you can't just do the integration like by putting a 2, right? Because it is the problem. You have for integration, you have the lower and upper limit. So if you start to put like 2 by after writing that equation and comma, it will gonna get confused because it has a lower limit and upper limit. Usually they put it like this equation, comma, lower limit, comma, upper limit. Okay, so that's why it doesn't work this way. So if you'd like to do the integration twice, the result can be defined with one variable. So like the result can be defined, say like y equal int of x cube, right? And then you'd like to do the integration again for y, whatever the result, right? So then you should be writing int, say like y1 equal to int y, something like that. Make sense? And that's again the indefinite integral. For definite, it's a different ball game. You got to put the limits. Okay. I think theory-wise that's all I have. Now we should be ready for the math. Don't worry, this math doesn't take that much of time. Now, here's the thing. I know, hopefully, Ben is watching this. Now the problem is, no, you know what? I can actually split this recording. So for this theory part, let me stop the recording here, and the second part would be for the programming. That would be in the different recording. Okay.